On to chapter 7, which is the last chapter in this module, which extends our study of the whole idea of inferential statistics. So remember, whenever we did chapter 6, we talked about a way to estimate what the true population proportion or the true population mean would be by using a confidence interval. Now we're going to look at a claim of what the population mean or the population proportion might be, and then looking at a way to test that claim to see if you have enough information based on a sample to say that the claim is true or not. Before we get into the actual parts of chapter 7, I want to talk about the vocabulary involved. In section 7.1, you will see us refer to the null hypothesis and the alternative hypothesis. The null hypothesis is what is accepted as true until proven otherwise. And the alternative hypothesis is what you are trying to prove. I want to point out something very quickly. You will see that in the null hypothesis, whenever we talk about the population parameter and what it could or couldn't be, you will notice that in all three scenarios of the symbolism that will be used in the null hypothesis, you have less than or equal to, you have equal to, and you have greater than or equal to. Notice that there is not anything relative to the equal to in the alternative hypothesis. So what you will be doing is testing whether your mean or your proportion is less than, greater than, or not equal to a given value for your alternative, but you will never include equal to as part of your alternative symbolism. That may help some of you decide. One of the hardest parts of this whole chapter is deciding which way to test your hypothesis. What should your alternative be? And a lot of times, because you'll be writing the null and alternative for each problem, a lot of times it's easier to write the alternative first. But as we go through these problems, that will become a little bit more evident. So for your chapter 7, it is about hypothesis testing, which is a process that uses sample statistics to test a claim about the value of a population parameter. Once you know what that claim is, then you're going to be looking at 3 options for your null and alternative hypotheses. You could be trying to prove that the mean is greater than some number. Again, that would be your alternative. And notice that these two are complements of each other. So the complement to greater than is less than or equal to, which would be the null. You could be trying to prove that the mean is less than some number for your alternative, so the null would be greater than or equal to that number. Or you could be trying to prove just that the mean is not what they think it is, and so the complement to that is equal to. So let's look at the verbiage of that and what it will look like as part of the steps that you will do for a hypothesis test. If you are determining that your alternative is less than and your null is greater than or equal to, then you will be indicating that the true mean blank, whatever the problem is about, is greater than or equal to some number. And the alternative is that the true mean blank is less than that some number. The reason I'm writing this out is because one of your steps will be to give me the null and alternative hypotheses in terms of symbols and in terms of statements. So on the second part, this would be that the true, and I'm just going to change it up and use average instead of mean. And when I put this line, that's the context of the problem. The true average, is less than or equal to some value. And the alternative, the true average blank is greater than some value. And then the third one would be the true average, whatever the problem is about, is some value. Or that the true average is not some given value. I want you to notice that in the symbolism in all three of these, they are written in terms of the population parameter. You're going to be using sample statistics to prove this, but the end result is that you're proving something about the population parameter. So to do that, just like with confidence intervals, you had a level of confidence. And hypothesis testing, you'll have a level of significance. So let's look at what that indicates. So we're talking about hypothesis tests. You will start with a null and alternative hypothesis written in terms of the population parameter. Your null hypothesis is your H sub naught. Your alternative hypothesis is your H sub A. And like I said, your alternative will never have an equal to in it. So if whatever statement is made includes an equal to, like if the statement says, I think a battery will last at least 2 years. At least is greater than or equal to. So that's got to be part of the null. Whereas the complement to that would be less than, and that would be the alternative. Once you have the null and alternative hypotheses, you will be given a level of significance that will relate to a rejection region. So let me show you what I mean by that. When we did probability on a normal curve a while back in chapter 5, we talked about unusual events. And if something had the probability less than 0.05 of happening, then it was an unusual event. Basically, what hypothesis testing does is it piggybacks off of that, and if it says, what's the probability that this should happen? And if it's very low, but it did happen because you had a sample and you got this value, so it's unlikely to happen, but it did happen. Then what happens in that situation is you will reject the null hypothesis in favor of the alternative hypothesis. So we need to know where this would fall, where that statistic would fall. If the mean is what it is claimed to be, the number in the null and alternative, and you have an area that's called a rejection region. And what you'll see is that your rejection region can take on 3 different possibilities based on how your alternative is written. So you could have a rejection region that is on the upper tail. And that happens when your alternative is testing greater than. You might have a rejection region that's in the lower tail of the normal curve. And you can probably guess that would be when your alternative is testing less than. These are called one-tailed tests. But you notice we had 3 options in our alternative. And that third option was not equal to. So if I'm not equal to, that means that I could be greater than, or I could be less than. And so what happens is this rejection region gets divided into 2 parts. This is your two-tailed, and it is when your alternative is testing not equal to. So I kind of jumped around. I'm going to go back because the level of significance correlates to the proportion in the rejection region. And you'll notice this third one kind of looks like a confidence interval, except the confidence interval was in between the 2 lines, and now we're talking about outside. This level of significance is alpha. It's your alpha level. So once you're given your alpha level, that's going to be the percentage that you will find in your tail. That percentage is going to correlate to your z-score or t-score that is associated with that percent in the tail. So just like in a confidence level, you had a critical value, in a confidence interval, you had a critical value. In a hypothesis test, you have a significance level that gives you a critical value for your rejection region. And what happens in the rejection region is if your sample statistic called the test statistic actually, let me just change that to if your test statistic, which comes from your sample, falls in the rejection region, then there is enough statistical evidence to reject the null hypothesis in favor of the alternative hypothesis. If the test statistic does not fall in the rejection region, there is not enough evidence and you fail to reject the null hypothesis. So it's kind of like the court system, how the court system works. It's not that you're guilty or innocent, it's that you're guilty or there's not enough evidence to prove that you're guilty. That's the same thing here. You either reject the null or there's not enough evidence to reject the null. So the conclusions you will draw will either be reject or fail to reject. So let's look back, and the document that I'm pulling up is your Module 3 document. And I'm not quite sure why it keeps doing this, but and so I want to talk about, I guess I'll go back to that before we look at the Module 3 document. When you get this test statistic, it will be a t-score or a z-score, just like you had t intervals and z intervals when you did confidence intervals. And that if it's a z-score, it will be the z value associated with the sample So X bar plus or minus, no, excuse me. X bar minus the mean divided by the standard deviation, which would be sigma over the square root of n. Or if it's a t-score, because it's a t problem, and we talked about in chapter 6 what indicates something is a t versus a z, and we'll talk about that and the difference between sections 7.2 and 7.3. You'll do x bar minus mu, but it'll be over s over the square root of n. And then in 7.4, when we do proportions, there'll be z-scores, and that will be p hat minus p over the square root of p hat times q hat over n. So your test statistic will be a value that your calculator will calculate for you. But this is what it's actually doing. It's getting a z-score or a t-score associated with the sample information that you have. Once you get that z-score or t-score, if you were to place that on your normal curve, then the probability associated with getting that test statistic or one more extreme is called p-value. So here's what happens. So this would be p-value. So you have a problem. You're given an alpha level, which again was your significance level. Let's say it's 0.05. And let's say that this is a upper tailed test. And that an alpha level of 0.05, and you'll have a z critical value associated with that. So then let's say you come along and you get a test statistic that falls in that rejection region. So let's say this is your test statistic. And since p-value is the probability associated with that test statistic, continuing on out to the tail, that's what that looks like. So you'll notice that this test statistic is in the rejection region. You'll also notice that the pink area, shaded area, is smaller than the purple area. The p-value is less than the alpha level, because alpha level and p-value are both probabilities, given probabilities or found probabilities. Well, I said before, if your test statistic is in the rejection region, you will conclude to reject. These two things are directly associated. So if the p-value is less than the alpha level, your conclusion will be to reject. And you can see that the pink area p-value is smaller than the purple area because it's inside that region. Let's look at what that looks like if you were to fail to reject. Again, let's say this was your alpha level. And then let's say you got this test statistic, but this time let's say your test statistic was out here. And so now my p-value that area is larger. If my p-value is greater than the alpha level, my test statistic is not in the rejection region. And therefore my conclusion is fail to reject. And I'm showing you this because you could be asked questions to base your decision on reject or fail to reject based off of a test statistic in a rejection region, or you could be asked based on a p-value and an alpha level. And bottom line, they should agree with each other. Always. So if the p-value is less than the alpha level, you reject. If the p-value is greater than the alpha level, you fail to reject. So looking back at your document, that's where up here you were given the level of significance, and you were, you can see here the alpha level. The most common ones are 10%, 5%, and 1%. And if you think about it, a 10% level of significance, which is on the outside, well, that kind of coincides with a 90% confidence interval, which is on the inside. A 5% alpha level, which is on the outside, that correlates to a 95% confidence interval. A 1% alpha level on the outside correlates to a 99% confidence interval. That's why those are the most common, because 90, 95, and 99 are the most common levels of confidence that we use. And so in this document, you can see where I was talking about the upper tail. I called it upper tailed and lower tailed. This calls it left tailed and right tailed, and then two tailed. So right here, you'll see if the p-value is less than or equal to the alpha level, you reject. If the p-value is greater than the alpha level, you fail to reject. Let's look at the idea of a claim that could be in a problem and how you determine whether that claim is the null or the alternative. And if you reject or fail to reject, what that actually looks like, because that's the way the problems will be presented in my lab stats. So let's look at this first example. A manufacturer claims that the mean life of a battery for a certain model of laptop is more than 6 hours. So I'm going to look at this more than 6 hours, and I'm going to write that as an inequality. Mu greater than 6. Well, since that does not involve an equal to, then that is going to be my alternative. So that's what I meant when I said sometimes you will write the alternative before the null, and it's all based on whatever mathematical statement can be made from the given problem. So if the alternative there is mu is greater than 6, then the null would be mu is less than or equal to 6. So this would be the true average battery life. For a certain model of laptop is at most 6 hours, or you could say less than or equal to 6 hours. And so the alternative would be the true average battery life for a certain model of laptop is more than 6 hours. So in this case, since the claim was more than 6 hours, then this problem, the claim, was the alternative. Let's look at number 2. A garden hose manufacturer advertises that the mean flow rate of a certain type of hose is 16 gallons per minute. So the mean flow rate is 16 gallons per minute. So that's mu equals 16. So since that is in terms of an equal sign, that's got to be the null. Because we can't have equal to's in the alternative. You'll never be able to prove equal to. Just like in a confidence interval, you couldn't determine exactly what the parameter would be. You could only get an interval. So this would be not equal to 16. And in this case, the claim is the null. So the mean flow rate of a certain type of hose is 16 gallons per minute versus the mean flow rate of a certain type of hose is not 16 gallons per minute. Number 3, an amusement park claims that the mean daily attendance at the park is at least 20,000. So that's mu is greater than or equal to 20,000. Because that has an equal to in it, that becomes the null. The mean daily attendance at an amusement park is at least 20,000. So my alternative is going to be less than 20,000 because it is the complement. So in this one, the claim was the null. Is less than 20,000. And so looking back up here, when you decide whether you reject or fail to reject, I want to draw your attention to this in the document as to how it will read referencing the claim. So in the first one, since my claim was the alternative, if I rejected, I would say there is enough evidence to support the claim, But if I failed to reject, I would say there is not enough evidence to support the claim. And the second and the third one, my claim was my null. So if I reject, I would say there's enough evidence to reject the claim. And if I fail to reject, there's not enough evidence to reject the claim. So make sure you make reference to that whenever you're doing your problems, especially in my lab stats. And that's the end of section 7.1.